Hey, I'm back as promised. So, got a sum, a difference, a product rule. What's next? Unsurprisingly, it's the quotient rule. Quotient rule is a little more complicated and it looks enough like the product rule to be confusing. So it's important that you keep track of these in your mind. So I'm going to call this F over G prime. So the prime, of course, means derivatives. It means a derivative of a product of functions. And that's F prime G minus G prime F, all divided by G squared. So you notice these two terms, F prime G and G prime F, are the same as the terms from the product rule, except they're subtracted. And there's a G squared on the bottom, which seemingly came out of nowhere, but trust me that it's supposed to be there. This is all with the assumption that G of X does not equal 0. Of course, because I need to have a 0 on the bottom of this fraction. If G of X is 0, then this thing is undefined to begin with, so it's not really that important, but this is the quotient rule. Derivative of the first times the second minus derivative of the second times the first, all divided by G squared. And again, there are cute little rhymey mnemonics for this. If you'd like to come up with one on your own, feel free. If you'd like to Google cute mnemonic for quotient rule, I'm sure you'll get some answers. But this is the rule. Memorize that however you'd like, but you will be expected to memorize this rule and the product rule. So we'll do an example. Fairly straightforward one. This is clearly a quotient of two functions. In our, this is like the top and the bottom. And if you go back to our rule, the top one was F and the bottom one was G. So it's like top prime bottom minus bottom prime top over bottom squared. So G prime of Z, in this case, is the derivative of the top, which is just 2Z, times the bottom, minus the derivative of the bottom, which is 3Z squared. Oh, that's an X. Try that again. 3Z squared minus nothing times the top. Again, I think of this as F prime G minus G prime F, all over the bottom thing squared. And I would not expect you on a test, on one of my tests, to be able to simplify this, but there's a multiple choice question you might have to. We should talk about simplifying at some point, but this is the basic use of the quotient rule. Derivative of the top times the bottom, minus derivative of the bottom times the top, all over the bottom squared. So pretty straightforward once you get a handle on the memorization of the rule. So this is another one of these things where they do it conceptually and they make you just know what the rules are and then plug in the values that they give you. So this is a product here. So the derivative of this is F of X, F prime of X, G of X, plus G prime of X, F of X. That's F times G. And this one is F prime of X, G of X, minus G prime of X, F of X, all over G of X squared. So I basically just rewrote the product and quotient rules here. I rewrote them because they're going to ask us about a specific X value, and they give us a table that has the values in it. So when X is 0, F prime of 0, G of 0, plus G prime of 0, F of 0. And I can just go back, I just look up here at my table. It tells me what everything is. So F prime of 0, I go to when X is 0, and F prime is -3. G of 0 is 1. And then G prime of 0 is 1/2. And F of 0 is 1. So that's -3 plus 1/2, which is -5/2. Again, we'll talk about simplifying at some point. Somebody remind me and we'll talk about it. I'm going to do the same thing here. I'm not going to rewrite it with the zeros in it. I'm just going to assume that you understand that to evaluate at 0, I plug a 0 in for every X. So the top is going to look a lot like this because it's all the same things, f prime g and g prime f, but I got to subtract instead. So it's -3 times 1 minus 1/2 times 1. The bottom is g of 0, which was 1, so 1 squared. So that doesn't even matter on the bottom. So this is just -3 minus 1/2, which is -7/2. 7/2. So I get -5/2 for this one, -7/2 for that one. Yeah, these ones are a little trickier, so I should probably do them. Okay, but same idea. First thing is a product. So I'm going to do f prime g plus g prime f. So I get f prime of x times x squared plus the derivative of x squared is 2x times f of x. But I want this one x as 1. So I'm going to plug a 1 in for every x. I'm actually going to write this one out. So I get f prime of 1 times 1 squared. I'm plugging in a 1 for every x plus 2 times 1, 1 for x times f of 1. F prime at 1, I go to the 1 row and I see f prime is 1/2 times 1 squared is just 1/2, so I'll write times 1 just for a laugh. Then I get 2 times 1 is 2, f of 1 is 3, so I get 1/2 plus 6, which is 13/2. 13/2, right? Yeah, it's 12 halves plus 1/2 is 13 halves, so that's good. And now I'm going to do the same trick here. I am going to use the quotient rule now, though, because f over e of x is a quotient. So I do f prime g minus g prime f all over g squared. So I do f prime of x times e to the x, so derivative of the top times the bottom, minus the derivative of the bottom, which we know the derivative of e to the x is still e to the x. Derivative of the bottom times the top, all over the bottom squared, e to the 2x. Well, yeah, just e to the x squared. Remember, we multiply these exponents, so that gives me e to the 2x. I'm just gonna, that's what that is. Okay, so I do f prime of 1. Yeah, we're doing this one at 1. So I'm gonna plug in 1s for all the x's. This is f of 1, right? So f prime at 1 is 1/2 times e to the 1. So 1/2 times e to the 1, which is just e, minus e to the 1, which is just e, times f of 1, which is 3, all over e to the 2 times 1 is 2, all over e squared. So that would be 1/2 e minus 3e all over e squared, 1/2 e. So we're almost done here, so I'm just going to finish this. 1/2 minus 3 is -5 halves, so it's -5 halves e over e squared, and cross off that e, and I get -5 over 2e. So there's some algebra in here, which you guys can kind of think about. You could like keep, switch, flip or something if you wanted to. Like think of this as e squared over 1 and then flip it over, but you're going to get this answer at the end. So product and quotient rules, both in their like kind of generic forms and in these like conceptual forms where I don't actually give you functions for f and g, I just give you values at specific points. You should be I expect you guys to understand how to do these at some point, and there'll be plenty of practice in class. Hope you enjoyed it. Bye.